Alrighty, hello there. My name is James, and we'll go ahead and talk about the strategy for integration. Let's go ahead begin with this problem. So we got cosine of x underneath sine, well actually 3 sine cubed of x dx. Okay, now how are we going to go about integrating this? Well, on the bottom right here, I went ahead and kind of listed some of the good steps that we should try to integrate any problem that we encounter. The first one we have is trying to simplify it. Now, if you have noticed, we have a tangent of theta does in fact equal sine of theta over cosine of theta. And we do have some sine of theta and cosine of theta, at least in terms of x, right here. But if we do that, we'll have something along the lines of tangent x, and then we'll have 2 more sine of x's. And this becomes a little bit trickier to integrate because sine is more related to cosine, and tangent is more related to secant. So in that case, we'll have to take a different approach. Now, it's always good to try, especially with these trig functions, to rearrange and try various things, but in this case, it's best if we keep it all in sines and cosines and not mix it around and introduce other things. So I'll go ahead and delete that. So one formula that we should know is sine squared of theta plus cosine squared of theta equals 1. Okay? And of course, instead of theta, you can write x, you can write, whatever other variable you would like to write, but this is essentially the formula. And if you notice, we have on the top, we have sine cubed of x. We can take 2 of those sine of x's and convert it into something else that'll make it easier for us to use this formula. And of course, this 3 right here can be factored out with no problem at all. So let's go ahead and actually do that. So we'll have 3, and if we expand it out, just so it's better to visualize, this is essentially what we have going on. Okay, and that looks fine, especially when expanded out like this. It's easier to see what we have going on. Let's go ahead and solve for sine squared of x. So we know that sine, I know I'm just using theta and x, like all these variables all at once, I know, but probably should have stuck with the x's, but that's fine. We got sine squared of x equals 1 minus cosine squared of x. Okay, so we can take 2 of these sine of x's, doesn't matter which ones, we'll just take it and we'll go ahead and convert it into something else. Specifically this 1 minus cosine squared of x. Okay, let's go ahead and do that. And be sure to use parentheses when you do it. Okay, and we got cosine of x. Now, at first glance, it doesn't look like our problem got more simpler. It looks like we just added another term here, and it's like, oh my goodness, what have we done? Are we even heading in the right direction? But as you'll see, in the next step, when we decide to distribute, whoops, wrong one. When we distribute the sine of x, we'll actually be able to simplify it further into 2 easier terms to integrate. So let's do that. So we'll have up here sine of x minus sine of x, cosine squared of x, all on top of cosine of x. And again, from the previous step, it looks like the problem got more complicated, but it's actually not. Because anytime you see a plus or minus sign, you can split up the integral. Let's go ahead and do that. So we'll have one integral of sine of x over cosine of x dx. And then remember this minus sign, right? We can break it up. So we have minus sine of x cosine squared of x on top of cosine of x again. Essentially, if you look at the long-term kind of goal that we had something complicated, and we just simply broke it up into two smaller pieces that are easier to integrate. Okay, so what exactly is this? Let's focus on the first one. Well, we know, and in fact I actually wrote it down, that tangent of theta equals sine of theta divided by cosine of theta. So we can actually rewrite it as the integral of tangent, not theta, x, minus, and now let's focus on this term. Well, we can see that on the top and the bottom we have some cosines which we can cancel out. In that case, we'll be left with sine of x cosine of x dx. Okay, so that looks pretty good, and we'll go on the next line over here. Now, what is the integral of tangent of x? We know that the integral of tangent of x is negative natural log of the absolute value of cosine x. Okay, and this is just assumed knowledge. Yes, there is actually a way where we can use u-substitution. U-substitution, and we can actually figure that out, but I will not be going over that in this video. And of course, let's not forget about this. We have the integral of sine x cosine x. So here we can use u-substitution. We have u equals, and what would be a good one to use? Let's try sine of x. The derivative of u would be cosine of x dx. And if it makes it easier, we can highlight this, our du, and the blue will be our u. And from there, we can see exactly what pieces are going where and how everything's going to be applied. So essentially, we have the integral of u du. Okay? And now let's go ahead, finish it off. We are very close. I can just smell the end. Okay. So when we integrate this, we're going to be using something called the power rule, right? And essentially, this has an invisible power, essentially to the first power. So we'll go ahead, add 1, and divide by our new exponent. So 1 plus 1 is 2, we'll divide by 2. And since there's no more integration symbols, right? There's no more of these things, then we can do a plus c. Now, of course, if you look at our original problem that we started off with, it's in terms of x. And so we cannot leave any u's in our answer. It has to be all x's. So in that case, we'll write this down again. Cosine of x minus, and well, we know that u is sine of x. So we'll do minus sine squared of x over 2 plus c. But we are not done yet. Why? Because we did not remember this 3 that we factored out a long time ago. So that's also an important thing to keep in mind. Let me go ahead and make some more space, kind of move some stuff around. And the real problem, or the real answer is, after we multiply everything by 3, it's going to be negative 3 natural log of cosine of x minus 3 sine squared of x over 2 plus c. And that, folks, is the absolute answer of this problem. That was pretty fun. Let's go ahead, try another one. It's going to be x to the 4th plus 4 underneath x. Now, how are we going to do this one? Well, if you look at the denominator, there's no plus or minus. It's just one term, right? So that, in that case, it is simplified. So we can rule that out. What about a u-substitution? Can we do a u-substitution? Well, we can try setting u equals the denominator, right? And usually you want to set u to at least 2 terms. That way it can cancel out more things. Because the derivative of a constant is 0. So if we have derivative of u, we'll get 4x cubed dx. Now, at first glance, that doesn't look very helpful to us. It's like, well, we don't have our du. I mean, we have our u at least. I mean, that's pretty helpful. But that x is by itself. What we can actually do is solve for x. And that way, we can actually get a better idea what's going on. Let me demonstrate. So let's solve for dx. And if we divide both sides by 4x cubed, we'll have du divided by 4x cubed. Now look, we'll have an x in the denominator and x in the numerator. So those will actually cancel out and give us something that could potentially be easier. So let's try that. So we have the integral x to the 4th plus 4, that's u. So we have x over u. And then what is dx? Well, we have dx right here. So it's going to be du over 4x cubed. These x's will cancel out. And I know it looks pretty messy, right? Because in our integral we have u's, we have x's. And that just makes life very hard for us. But if we trust the process, we should be able to get through something much easier. And of course, there's a 4 right here. So we can take out that 4. It's just a constant we can factor out. And let's see what we have going on. So we have u x squared over du, underneath du. Now, how are we going to go about this? Well, if we look at our u, we can try solving for x and see if that will bring us any closer to the solution. So we have x to the 4th. Now, if we just square root that, we'll get x squared, because we're looking for x squared. So let's try that. We know that x to the 4th equals u minus 4. And I'm going to go ahead and write it again. Why? Because we're going to square root both sides. Now we have x equals the square root of u minus 4. And we can plug that in there where it's highlighted red. So we have u times the square root of u minus 4. And this is our new integral. And so with u-substitution, especially with a problem like this where, spoiler alert, we're going to be doing multiple u-substitutions, it's important to be organized. Okay, so I'm going to go ahead and select this, move it down here. Now here's our new integral. It still looks pretty messy. How can we go even further and actually clean it up some more. Well, let's suppose that we have a new variable v. V equals u minus 4. Okay? And what is the derivative of v? Well, it's going to be, in this case, it's going to be du. Okay? Now that can help quite a bit because we have u minus 4. But what is u equal? We need to know what u equals in terms of v. And what we can do is if we add 4 to both sides over here, we have u equals v plus 4. And we can go ahead and plug that in there and we'll see what do we get. So we have 1/4. U is v plus 4 times the square root of v. Okay. Now, did this help us anymore? In fact, it did. Because now we can easily distribute the square root of v into both terms, and we should be good to go. From there, it's going to be significantly easier to integrate. Let's move this out of the way. So you'll notice that in our steps, we keep referring back to u-substitution. U-substitution is a very powerful method that we have to integrate problems, especially if you can find it. Sometimes it's pretty well hidden. So we have v times the square root of v plus 4 square root of v, all underneath du. Well, we know that with the power rule, we have v to the first power times v to the 1/2 power. This is the same as v to the 3/2 power. Because when you multiply these powers, it's the same thing as adding them. Okay? And we get v to the 3/2. So we can actually rewrite this as v to the 3/2. And what about this 4 times square root of v? Well, in that case, there's not much we can do with it, unfortunately. It's stuck there. And because we have a plus right here, we can't add them because they're not like terms. Now, in this case, we have chosen the wrong value of u, because this does not make the problem any more easier to do. So let's try another value of u. So we'll have, or v. So let's delete what we have in the box over here. So we have v equals, let's try v equals the square root of u minus 4. So what would the derivative of that be? And let's go ahead and delete this stuff because it is not correct. At least it doesn't bring us to an easier solution. Let's go ahead and get that too. So we know that we have the square root of u minus 4, and when we take the derivative of it, this is essentially the same as u minus 4 to the 1/2 power. We'll bring that power down, and then we have the subtract 1. So we have u minus 4 to the negative 1/2, which is the same as u minus 4 times 2, all underneath 1. And if you actually look, then you can see we actually have something like this going on. So that's good. So dv is going to be 2 times the square root of u minus 4 underneath 1. Well, in order to do that, and let's go ahead and move these aside, what we have to do is, there's a few things we can do, but we can move 2 into the denominator, which will get us 1/2 2u times the square root of u minus 4 underneath du. And let's go ahead and start highlighting what we have. So dv is this. So we do have this portion, we have this portion. So that's a good start, and we can begin rewriting. And actually, there's actually going to be a du on the top. So what do we get? Essentially, we have dv over u. And I know my v's and u's look pretty alike. This is a pretty common problem that sometimes students face. Well, if we go ahead and solve for u, it's going to be v squared equals u minus 4. And then if we add 4 to both sides, we have v squared plus 4 equals u. So let's go ahead and do that. 1/2 v squared plus 4 all underneath dv. Now, compared to our previous integral that we tried to set up, this is significantly easier. This is going to bring us something along the lines of arctangent. Because we know that x squared plus 1, if we take the integral of it, this will give us arctan of x. So if we can get it in that form, that would help us a lot. So how can we do this? Well, if we go ahead and factor out this 4 from the denominator, we'll get 1/2, and then we'll get a 1/4. That's going to be v squared over 4 plus 1 underneath du. And let's bring this a little bit lower so it's a little easier to see. And you notice if we multiply this 4 out, it's still going to be the exact same as we had before. Okay, let's go ahead, factor out this 4 completely, so we'll get 1/8. And now what do we have going on over here? It says v squared. Let's focus on this. If you notice that 2, this 4 right here, the square root of 4 is 2. So if we do 2 squared, that equals 4. And so what we can do a little algebraic trick here. We can do v over 2 squared plus 1. And that is supposed to be a v. Okay? And now if we set another final variable, so let's go ahead and start removing some stuff to get some more space. Suppose we have w equals v over 2. The derivative of w is 1/2 dv, and the 1/2, we'll just factor that in real quick. So we have 1/4, the integral of 1/2, and v over 2, that's w, so we have w squared plus 1 dw. Okay, and again, this dw, just as a reminder, it's actually absorbing this 1/2. That's kind of one way to think about it, so we can delete it. And now it's going to be arctangent. So let's go ahead, make some space as usual. I know our work can get so messy real quick. Equals 1/4, and it's going to be according to that formula, which I'm just assuming that we just know that. It's going to be arctan of w plus c. And what does w equal? Equals v over 2. So let's do that. 1/4 arctan v over 2. And then we have to do one final one. Again, let's try moving these a little bit out of the way so we can do our final thing. It's 1/4 arctan of, and what is v? V is the square root of u minus 4. So we got u minus 4 plus c. And then we can do one final one here because, again, our question was originally given to us in terms of x. And so we have 1/4 arctan of, drum roll please, x to the 4th, and this plus 4 and minus 4 are gonna cancel out. The square root of that over 2 plus c, and again the square root of x over 4 is simply x squared. So that's one way to simplify our answer, and we are officially done. Can you believe it? So what a problem.